This is Pre-Calculus A, Unit 7, Lesson 5. Pardon me, I didn't get my screen ready in time. We are learning arithmetic series summation formulas. So we're going to introduce something called sigma notation. Let me show you just by using an example. This is the Greek letter sigma. You might see it in some college sororities on the outsides of their buildings, etc. It's the capital letter sigma. The lowercase sigma is like this. Okay? But if you draw it properly, it looks kind of like this or like that. But for practical use, I do something like that. Okay? But it stands for the sum of. The sum of. Now I'm obsessing over how I'm writing it. Oh well. Okay. This is going to be the sum from I equals 1 to 4 of I squared minus 5. Okay? And here's how this works. Basically, I is called an index. Index, not Windex, index. And an index basically is a counter. It starts at 1, but then it takes the value of 2, the value of 3, the value of 4. It's going to take on each whole number value from the index start number to the index finish number, which is 4 in this case. So we're going to let I equal 1 squared, minus 5. We're going to let I equal 2 squared minus 5. We're going to let I equal 3 squared minus 5. We're going to let I equal 4 squared minus 5. Okay? And so this turns out to be 1 minus 5, or negative 4. 4 minus 5, negative 1. 9 minus 5, which is 4. And 16 minus 5, which is 11. Okay, cancel there, and we end up with a partial sum of 10. Okay, so that's an introduction to sigma notation, and you can imagine it can be used for expressions that are immensely complex. All right, let's go back to our example of an arithmetic series. So let's say we have the arithmetic series 5 plus 8 plus 11 plus 14 plus 17 and so on. This you'll recognize as an arithmetic series with a common difference of 3 and a start value of 5. You may recall that the nth term here, the nth term is a sub 1, 5, plus n minus 1 times the common difference 3, right? And so that then is our general formula for the nth term of the series. We can express this as an arithmetic series if we're using summation notation like this. For I equals 1 to n, we're going to let the nth term be 5 plus not n minus 1, but I minus 1 times 3. Okay, and we can simplify this here a little bit. That's 5 plus 3i minus 3, the sum from I equals 1 to n. And this is the way you're going to typically see it here. You're going to see the sum from I equals 1 to n of 2 plus 3i. Okay? And so that's the notation for this. This equals the sum from I equals 1 to n of 2 plus 3i, right? Now there are some shorthand notations. First of all, I want to give you some rules about summation. Okay, if I have the sum of a sub I plus b sub I, we can take the sum separately. The sum of a sub I plus the sum of b sub I. Okay, so we can break this up. So this is also the same as the sum from I equals 1 to n of 2 plus the sum from I equals 1 to n of 3i. Okay. What's more is if I have the sum of some constant times some ith term, I can take the constant out and multiply that. I can basically factor out the constant and multiply it. It's constant times the sum of all the a sub i's. Okay, so another way to write this is the sum from I equals 1 to n plus 3 times the sum from I equals 1 to n of I. Okay. All right, so let me show you how that is used. Okay. Or actually, there are 3 formulas given in the lesson here. I'm going to give you an extra one. The sum of k from I equals 1 to n is kn, right? So in other words, if I had the sum of 5 from I equals 1 to 4, that would be 5 plus 5 plus 5 plus 5, which is 4 times 5, right? It's kind of logical when you think about it. Okay, the sum from I equals 1 to n of I, that's a little bit different here. I'm going to derive this formula here, and hopefully we'll be okay with time. So I'm gonna derive this formula. So the sum from I equals 1 to n, let's do the sum from I equals 1 to 4 of I. Okay, that's going to be 1 plus 2 plus 3 plus 4. Now you may recognize this. This is an arithmetic series, right? Common difference is 1 and n is 4. Or you may think of it as, remember we kind of reversed the order and added. This is 5 plus 5 plus 5 plus 5, which is 5 times 4. But that's 2 times what we need, so we divide by 2. Okay, so 5 times 4 times 2. Now notice what this is. N is 4, right? And so this actually is n times n plus 1 divided by 2. 4 times 5 divided by 2. Okay, so it comes from an arithmetic series. But this is a good one to know. We also have the sum from I equals 1 to n of I squared being n. I don't have these memorized, so, and I should actually. Usually by the time we do a few problems, I've got it memorized again. But divided by 6, and the sum, and there are more formulas here. These are the ones given in the lesson. Of the I cubed is n squared, n plus 1 squared, and the derivation of these formulas is much more involved, divided by 4. Okay, all right, and we can use this to evaluate series, evaluate partial sums. So let's say I want to do the sum from I equals 1 to 15 of 4i squared plus 3i minus 2. I can now do that by doing this. That is 4 times the sum from I equals 1 to 15 of I squared plus 3 times the sum from I equals 1 to 15 of I minus 2, or minus the sum of 2, if you like. We'll do it that way. The sum from I equals 1 to 15 of 2. Okay, let's use our formulas. The sum of the I squareds is 4 times I squared n 15 times 15 plus 1 times 2 times 15 plus 1 divided by 6 plus 3 sum of the i's from 1 to 15. That's going to be 15 times 15 plus 1 divided by 2 minus the sum from 1 to 15 of 2, which is going to be 2 times 15. Okay? And I'm going to leave the rest. If you want to do the arithmetic or punch it on a calculator, you can do that. But that's the sum of this particular series. And we could have done this by writing out the series, the first 15 terms, and then summing them up. So I'll leave it to you as to which is easier. But it certainly would be easier to use this formula if I had been adding the first 45 terms instead of 15, which would be in the realm of not too crazy to do by hand. All right, so hopefully that makes sense.